Hello and welcome. I'm Habib Haydarian, and I'm a program manager in Visual Studio. It is awesome to see so many people on the last day of PDC, so I'm extremely relieved and happy to have so many of you in the audience. I work on tools like debuggers, code analysis, profilers, and so forth. So pretty much anything that goes wrong with your code, I'm the guy that you can hassle and harangue. If you are a developer today, and I'm assuming that most of you in the audience are, you are going to absolutely love Visual Studio 2010. In fact, I am so convinced that you're going to love VS 2010 that I've put my personal email there. And if at the end of this session you are not convinced, please send me an email, and I'll guarantee you a 24-hour turnaround. And tell me why you don't love Visual Studio 2010 if you are a developer. If you're not a developer, well, then. OK. So why am I so convinced that you're going to love Visual Studio 2010 as a developer? There are 4 scenarios that I'm going to show you today that are all about application quality. We've made it so much easier to debug applications and also be able to figure out what impact your code changes will have that I think developer productivity will be immensely improved in 2010. Specifically, I'm going to talk about these 4 scenarios. So number 1, I'm going to talk about how you can diagnose hard-to-reproduce bugs with VS 2010. Scenario number 2, we're going to talk about the infamous one-line code change and how that never has any impact on your application. Number 3, we're going to talk about multi-tier performance analysis. Most applications today, in fact, in enterprises, I'm going to claim all applications are multi-tier. And if you have a performance problem, well, how do you analyze that performance issue when you have a distributed application? And last but not least, we've made it a lot easier to debug complex problems. I'm going to show you 2 specific examples. One is around using dump files and doing crash analysis. And the other one is a scenario that we call collaborative debugging. So let's stop with the marketing show and actually get started. Every single developer that I've talked to, this is reality today. And let me tell you what that is. As a developer, you write some code. You make sure that it's of high quality before you send it over to the wall, to the tester. And at which point the tester picks up the bits, starts testing it, and finds 1 or more bugs. Sends you an email, or if you have a work item tracking system, the person sends you a bug. And then at that point, you actually try and repro the issue and then say, well, it's not on my machine, and just send it back. And by that time, the tester wants to kind of wring your neck. But this is reality. In fact, I'm going to be perfectly frank with you. At Microsoft, we deal with this on a daily basis also. So it's not unique to just the people in the audience, but we suffer from the same thing. What we want to do in 2010, we want to get rid of this problem. And we're going to do that with a feature called IntelliTrace, which I'm sure almost all of you have heard of. The easiest way for me to explain what IntelliTrace is and I'm sure the scenario that I'm showing there doesn't apply to any of you, but let me just go through it. If you have an application today, what typically most developers do is use what we call printf debugging. You add some explicit instrumentation. Let's say in this case you're using debug.writeLine. And then at the end, you'll end up with a wonder called Notepad. Then that you glance through. I've seen a lot of folks write their own Perl scripts, anything else to allow you to scrub what's in the log file and then be able to actually make sense of it. This is troublesome for 2 reasons. One, you're not touching your application, making code changes to be able to debug your app. And 2, trying to grok through a 10 meg notepad text file is a lot of work. So let's look at how IntelliTrace changes that. So we have our application, and with IntelliTrace now, you get 3 key capabilities. You get recording, you get playback, and you get rewind. That's right, rewind. So you can now step back in the debugger with IntelliTrace. And I'm going to show you 2 specific examples of what that looks like. So we're hoping with IntelliTrace, you're going to get rid of the whole notepad scenario and having to grok through lines and lines of text, and now be able to have a first-class experience in Visual Studio. OK, let's go through the first scenario. I am sure all of you have BVTs, or build verification tests. And if you don't, shame on you. And in this scenario, let me show you what that experience looks like now with IntelliTrace. So I'm going to bring up a build. This is team build, by the way, of an existing build. And I'm going to kind of try and investigate why the build failed. So the fact that I've got a small x next to my build shows that something went wrong. Well, when I look at the actual build report itself, it's showing me that 24 out of the 30 tests passed. That means, obviously, 6 failed. And let me look at the test results to find out why that happened. And this will now show me the list of tests that have both passed and failed. And what I should be able to do is, that's right, this laptop is OK, here we go. Now let's try and diagnose one of those failed tests. So let's pick on the first one that says, you know what? If you have 2 products with a price of 5, the total should be 10. So I'm going to double click on that and bring up the results. And you notice that now you have an IntelliTrace log file attached to the test result. So what happened here is that when you ran your nightly build and you were running your tests as part of that, IntelliTrace was actually running as part of your test suite and recorded everything that the application was doing. And let me describe to you what I mean by everything. So this is the IntelliTrace summary page. Let me go ahead and expand this so it's easier for folks to see exactly what's in this file. The first thing that you notice is we'll now record all the thread lifetimes and show you exactly when a thread started and stopped. I'm not sure exactly why this is not showing up correctly. The other thing that we'll show you is the actual exception data that's captured in the IntelliTrace log file. And last but not least, you'll also see the test data as well as system information. So the system information includes things like what the architecture was, as well as how much RAM you had and so forth. And for each one of these criteria, you can now filter out what you do or you don't want to see. All right, so how do I go about debugging this right now? Well, the way I can do that is as simple as selecting the exception. And you can see that we also display the call stack for the exception, and double click on it. What this will do is that it will literally replay what the application was doing. Not only that, it takes you to the exact source file, but tells you every single thing that your application was doing before the exception was thrown, right? Think about it. How would you do this today, right? You might actually try and run the test yourself, and hopefully you'll be able to repro the problem. But the process of debugging the problem, which is essentially a binary search where you reduce the problem space, that can take hours and hours and hours. All I had to do here was load up the IntelliTrace file, double-click on the exception, and it took me to the exact line. But what's super cool here is the fact that, ladies and gentlemen, I am not debugging this application right now. This has all been recorded for me. What I can do at this point is go to IntelliTrace and actually step back in the debugger. In fact, we have now a shortcut key, which is Control-Shift-F10, and I can, in fact, F11, I'm sorry, and I can just step back in my application, to figure out exactly what happened as the application was running. So how is that for your experience? But wait, there is more. What's really important here is that not only am I seeing the code that executed when the application was running, but I can also see the various events. What we do is that we record various types of events. For example, record all the ADO.NET calls to my database, record all my web service calls to my database, record everything that has to do with data binding, right? So not only can you see how your application executed, but you can also see the exact set of exceptions that were thrown, what were the files that were accessed, what were the ADO.NET calls. But what's also really easy to do is if you just want to filter out the type of events that you're interested in, you can literally say, you know what, I'm only interested in the ASP.NET events. Or let's say I'm interested only in the ADO.NET events. Let me just get that right. Okay, apparently we don't have any. Oh, that's right. This, let's try another one. Let me actually show you, filter out, so I only see the exceptions. But what's also really cool here is that you can go one level deeper, and you can filter out by the, let's say, a string or something that was recorded as well. So it now makes searching through the space of the recorded events that much easier. So if I say, let's say, show me all the accesses to the HKLM registry key, I can just filter that out and it'll show me just that list and nothing else. So again, personally, I think this is going to completely change the way that people debug their applications, because now you have pretty much a full fidelity log file that you don't have to actually grep through using Notepad, right? You have a Visual Studio experience that allows you to debug exactly what happened. But what's also really cool here is that obviously not only can I go backwards, I can now kind of, just like your favorite DVR, I can go forwards and backwards through my application and see exactly what happened. So let's actually just, now I can also step back in time into the method. So literally, folks, I'm going to step into it, and that takes me back all the way into exactly what the method was doing previously. I can continue stepping through this. And one of the biggest kind of complaints that we get today is, I really wish I could see the return value of a method, right? That's a very common request. Well, what we've done with IntelliTrace now is you can simply expand the method name, and guess what? We've actually recorded the return value. So I think this is going to be another tremendous benefit, because you no longer have to wonder, I wonder what was the return value of that method. But there's one other really cool, subtle scenario here that I want to show you, right? How many times do you come across, let's say, a switch statement or if statement, and you're wondering, I wonder which one of those branches my application took when it was running, right? Well, with IntelliTrace, because we recorded the branch information as well, you can now know that, guess what? The application took this path through the if statement and not the other path, right? And suddenly, your debugging completely changes now, because it's no longer guesswork, because we have recorded the exact execution path, not only across the program, but also across the if statements, switch statements, and so forth, in the actual application as well. So I am not excited about this IntelliTrace, as you can see from here from the tone of my voice. OK, so let me go ahead and stop this for now. Yeah, let me just stop this and go back to here. You're wondering, OK, so how is all this magic happening? I think it's important to know the capabilities of IntelliTrace. As I mentioned, the way IntelliTrace works is that it dynamically instruments your code, right? you are, as a developer, you're not adding a single line of code in your application for IntelliTrace to work. It just records your application without you having to do anything. As I mentioned before, it records program execution flow. So method enters. I'm sure many of you do the typical, debug.writeLine, enter method, foo, exit method, foo. Well, that's all done for you automatically now. Records program data, specifically includes parameters and return values. And what we have is we have this, what we call pay-as-you-go collection model. Let me explain to you what I mean by that. So imagine a dial, right? By default, the dial says, I want you to only collect this amount of information, right? But guess what? If you want more information, you grab that dial and then crank it all the way to the right if you want, right? And that will record as much information as you want. However, just like any other kind of recording framework or instrumentation framework, the higher you turn that dial, there's an inverse relationship to the performance of your application, right? So there are instances, I've talked to many developers that are like, you know what? I really don't care how much my application is impacted. I really need to debug this hard-to-repro problem. Therefore, they just crank it all the way up and debug the problem. But by default, we definitely have set the recording level to not have, to have very little impact on the application. Okay. Let me show you another demo. One of the most common questions that developers ask as soon as they get a bug is, how did I get here? Well, think about it how you do that with a debugger today, right? You use two tools primarily. The call stack window, which shows you all the live frames on the call stack. And the other old technique is obviously via instrumentation. So let's go back to our favorite application. And let's say I am now the developer, but I'm debugging this application live, meaning that I pressed F5 on the application. I'm sure maybe some of you have seen this Tailspin Toys application. It's just a very simple two-tier application that allows a user to order various toy airplanes. This is running right now on the local ASP.NET web server. However, this scenario works equally as well in IIS 6, 6.1, 7.0, and 7.5. OK, so you're a developer right now. You're going through your application to exercise a bit of the functionality. I just clicked on the model airplanes. Let me add, I don't know, fourth coffee flyer at $50. Add it to the item. Add the item to the cart. Once I've done that, let's say I want to add one more item of the same model airplane to the cart. So let me just click on that. So you can see right now the quantity is set to 1. Let's click on that. So it takes me back to the previous page. And kind of the typical expectation is when I press add item to cart, the quantity should be up by 1. Right? So obviously, we have a bug in this application where the quantity is still 1. How do you go about debugging this today, right? If you attach a debugger, right, the problem has already occurred. You can't go back in time and say, I wish I knew what actually happened. And the other thing is, what most folks do is one of two things. They will manually attach the process, hoping that the problem will repro again, or what I have seen 90% plus of developers do is that they shut down the application, right? Then they use their index finger on the F9 key and try and set breakpoints, hoping that it'll actually be in somewhere in the application where the problem is. Well, the nice thing with IntelliTrace is I can just say, you know what? Let's just break. Now, by default, right now, because the application was kind of executing in the ASP.NET web server engine, we don't really know anything about that. And therefore, by default, we'll display a page telling the user, you know what? There is nothing to see at this point. But this is where the IntelliTrace window comes in very, very handy, right? The first thing is this is an ASP.NET application, right? So therefore, what I really care about, you know what, are just ASP.NET events. Great, I only see the ASP.NET events. And if you look at this right now, I mean, I personally would have loved to have a feature like this forever, right? I can see when a specific page was requested, when was it redirected to, when was it posted to. You can now see exactly how your application executed when the ASP.NET request came in. But wouldn't it be nice if you knew what the correlation between the page request and your code was? Well, you can do that now because you can simply click on one of these events and we'll take you to the exact source line where the ASP.NET event happened, right? So, and if you remember, the action that I took was to add an item. Guess what? There is the add item event, right? But what I'm going to do here is I want to see the correlation with my source code. So I'm going to click the calls view, and ladies and gentlemen, this is the coolest feature of all. And let me tell you why. Not only are you seeing the actual events, but the calls that happen as a result of the events, right? So event A happens. I wonder what methods were executed when event A happened, right? We will tell you now because this is the exact set of calls that were made as you clicked through your ASP.NET page, right? And in this case, what I did was I did an add item, and guess what? When I pressed add item, the add item method was called. Now I can double click on the add item method, and it will take me exactly to the place in my code where the method was called. So not only can I see exactly the set of methods that were executed, but I can see the events that resulted in that method. And if you look at what we call the calls view in the IntelliTrace window, this just blows my mind. It says function entry, function exit, and all the calls that were made in between it, right? How many times as a developer do you yourself add that instrumentation to your code to say, you know what, method enter, method exit, and I wish I had everything that happened in between? Well, with IntelliTrace, we'll tell you exactly what happened in between. Not only that, we'll tell you what your code is, but also if, as a result of your code, a .NET Framework method was called as well. So we grade that out, telling you, hey, yeah, there was some other code called that might have some other side effect or impact on your method. So the question of how did I get here, right, with IntelliTrace is that much easier because we will tell you not only which methods got you here, but which events got you here as well. Okay. I love doing the under the hood sections of my talk, so I'm going to show you how the magic of all this happens. All right. So what you have is, in this case, Visual Studio, right? I'll press F5 in Visual Studio, and as a result, two things happen. Visual Studio first starts your application, but also it starts a process called the IntelliTrace recorder, which basically records, obviously, the application behavior. But before the IntelliTrace recorder starts up, it actually queries for a file called the collection plan. You know how I talked about that dial where you can grab that dial and turn it to the left or to the right? This is your dial, right? This is the thing that tells the IntelliTrace recorder what information I want you to collect. So in order for you to kind of dial that, turn that dial up and down, this is the file that will be edited. But I'll show you what that experience looks like. Once the IntelliTrace recorder loads up the collection plan, it starts recording, right? It starts recording, and then what it does is it generates a file called the IntelliTrace file. And just like your favorite DVR, it is a recording of your application, right? I want to make it very clear that in IntelliTrace, when you step back in the debugger, we are not re-executing your code. You cannot go back in time and kill your grandfather. That's not a supported scenario. Because That's a very common question, right? Because you could actually, if we were reverse executing your code, you could go back in time, change what happens in the future, and then suddenly you end up in this very, very bizarre world where your granddad is dead, but you're alive. Okay. And then what happens is, as soon as you say pause in the debugger, we actually then take that IntelliTrace file and then load it in the Visual Studio. So let me show you a couple of those artifacts. The first thing I want to show you is what this collection plan looks like. The other thing that I want to show you is this IntelliTrace file. All right. The way you want to access both of those features is through Tools Options. So Alt-T Options. We won't have enough time to go through all the features, but I really want to encourage you to go through this because it has an amazing amount of functionality in here. By default, you can say, you know what, I don't want IntelliTrace to be on at all, in which case you can just go and turn it completely on and off. And we have 2 levels of high-level recording. But if you really want to get fancy, here's where you can start playing around with the bits. Now, you can imagine if you have an application that is running forever, and I mean a couple of days, the log file can get very, very large, right? You have a WCF service sitting around, requests coming in, right? And that log file is growing bigger and bigger and bigger, and suddenly, you're out of disk space. Well, we have a feature called we have the ability in IntelliTrace to limit the size of that log file. So what happens is, as soon as the recording completes, we turn around and basically overwrite the log file. And how you use this feature is you can basically specify, let's say, a large log file, in which case, depending on how long the application been running, you can say, you can kind of, by using the log file size, specify, I want to record the last 5 or 10 minutes of what the application was doing. The other thing that I mentioned here is the IntelliTrace log files. And it's in a directory called program data. And here are the list of all the log files, IntelliTrace files that were recorded as you were running the application. But you know what's really nice? At any time, I can just go back and double-click one of these and start debugging the application, right? And I basically end up with the exact same summary page and then kind of resume my debugging session where I had left it off. The last thing that I want to cover as far as IntelliTrace is concerned is these events, right? As I mentioned, there are many types of events that IntelliTrace records, and you can go ahead and essentially uncheck the events that you are or aren't interested in. Okay. So that was the first scenario where IntelliTrace helps you to diagnose hard-to-repro problems. But very importantly, IntelliTrace now allows you to step back in the debugger. I think that's a really important feature that we're hoping will make developer productivity that much better. Let me explain to you this problem of choosing the right tests and why it impacts the developers just as much as it impacts testers. The large circle there is meant to represent the application domain or the entire application functionality. And I would claim that no matter how thorough your testing is, regardless of whether it's automated testing, which includes things like unit testing, manual testing, user testing, and so forth, your tests will never cover the entirety of your application. There are just way, way too many combinations. So the question is, you're a developer now, and you made a code change, right? Represented by that little delta that I've highlighted in the application. You made a code change that basically, in the entire space of the application. Let me ask you this. Which of these tests should the developer and tester run? Should they only run the automated tests? Should they only run the manual tests? Should it be all of the above? Don't know. It's a trick question, right? I mean, this is something that organizations struggle with all the time. And what's the consequence of that? The consequence is the fact that developers either are like, I don't feel like running my tests. It's going to take me half an hour to run them. Let me just run a couple. Or let me just run all my tests and I'll go out for coffee and come back in half an hour or two, right? I mean, that really, if you're an agile developer, that kind of starts to kill your productivity as well. Now, if you're a tester, you come in the next morning and you're like, I wonder what I have to test today, right? And then you find out that there was one bug fix, right? How do I know which test to run, right? And manual testing is extremely expensive because it's very labor intensive, right? So what happens is, depending on how close you are to ship time, you either test what you think are the right set of tests, right? Or you test everything because you're scared that you might miss something. All right, so that brings me to the feature that we've introduced in 2010 called test impact analysis. And the easiest way I can explain to you what test impact analysis is by this example, right? So you're a developer right now, and you're sitting in front of the IDE, and you want to make a change to this method. And the change is as a result of a bug that a tester opened against you. And the bug says, you know what? We're not handling negative quantities correctly, right? So what did you do as a developer? As a developer, you're like, well, let me just go ahead and change that. And I'm going to make sure that basically the quantity, the total quantity can never be a negative number, right? That's my bug fix. Now, is this a good bug fix? A bad bug fix? Don't know. Hopefully it'll turn out well. I mean, that's a very important question that most people, unless they're absolutely an expert at the application and know exactly how it behaves in all various ways, cannot answer, right? So what is the impact of this change? And what test impact analysis allows you to do is it allows you to answer that exact question. So let's go through an example of the infamous one-line bug fix. Okay. Let me pull up my one of my favorite features, which is Navigate to. I love this feature. All right. Now, because I'm terrible at typing and I'm quite lazy, I'm going to literally copy that one line of change. And paste it right here. That's the bug fix, right? Now, let's see whether that was a good bug fix or not. But before that, wouldn't it be nice if the tool would actually tell me whether how this change would impact my tests? Well, I'm going to bring up a new tool window that I've introduced called the Test Impact View, which by default, oops, should say no tests were impacted. But I had rerun this scenario. Let me just go ahead and do that. But as soon as the scenario is, as soon as you build your application, we will then basically calculate how your change would impact the set of tests in your solution, and also any manual tests that were run against the application, and display those in the test impact view. So what I can do at this point is you can see that, let me just expand that window as well. I have 21 tests that are impacted if I were to make that code change. Now, let's say as a developer now, if I could choose to ignore this, right? But what we've done is that we've actually enabled a policy so that if, as a developer, you choose to ignore the set of impacted tests, right, will actually warn you about it. So here what you can see is we have 21 tests that are impacted, but the overall number of tests, let me just bring that up, were actually 30. There we are. So okay. So there were 30 tests in my solution, and you can obviously see the number 30 right there, and 21 of them were impacted. So what I'm going to do at this point is I can simply go ahead and run only the set of impacted tests. Let me just go ahead and do that. And as soon as that completes, what you'll see is the test impact view will then clear the list of impacted tests. And then I can go ahead with my fix. So to answer the question of how impactful was that test, was that fix? Well, we'll be able to see now because the set of impacted tests will tell us once this is done. Yes, my laptop is powered by hamsters, literally. The question is this work with 64-bit? And the answer is yes. That's actually, let me tell you why. What we've done in 2010 is we've actually added support now for 64-bit test execution. And as a result of that, that means that this feature will also work for 64-bit as well. Okay.
Is it possible to record the test in a server without Visual Studio using the command line, get the recording, analyze it?
Okay. So let me, I'm going to repeat the question back, and then hopefully you can correct me if I'm wrong. The question was it specific to test impact analysis or IntelliTrace? Which one? So the question was with IntelliTrace, right? Can you use IntelliTrace or copy IntelliTrace to a location where Visual Studio isn't present and run the IntelliTrace command line, or let's say some utility, collect the log file and bring it back to the IDE. The way you can access IntelliTrace, the actual collector itself, are three ways. One is install Visual Studio. The next one is install a new tool called Microsoft Test and Lab Manager. And there's the third way, which is install the test agent that would do that. So the answer to your question is no, you don't have to install Visual Studio, but there are two other ways that you can do it. But you cannot kind of just copy the IntelliTrace recorder as a single binary and then record and then bring it back. All right. So it looks like that was a terrible, terrible, terrible fix. In fact, in the words of Donald Trump, if I were a developer, he would have fired me on the spot. In fact, it was so bad that let me show you how bad this fix was. Okay. I'm just going to run the application. It was so bad that when a tester came in the next day, and without impact analysis, this is what they would have seen. Model airplanes. Just do that again. Delete. Right? So imagine this now. If today, if you make a code change, this is exactly what some organizations have to deal with, right? You will now bring down or stop a number of folks from working because, you know what? The build went through fine. But the problem is the actual functionality was the thing that was broken. Okay. Again, I love the under the cover or hood slide. So I'm going to talk about three things. There are actually three experiences with test impact analysis. The first one that I showed you was experience A. The way it works is there is essentially a database, a local database, where we record the mappings between a method and the set of tests that call that method, right? And from then on, as soon as you touch anything inside that method, we will flag that as, hey, this could have an impact, right? So that's the first experience, and that's the one that I showed you in the experience. However, the two other experiences there are, and let me start off with B, is the fact that I'm not sure how many of you went to Vinod's talk this morning around Lab Manager. There's a tool that it's called the Microsoft Team and Lab Manager, where now as a manual tester, when you come in the next day, you know exactly the sort of manual test that you need to run, because what happened was, when as part of you running the team test and lab manager, I can't even say those words, you now essentially know, again, what functionality your manual tests touched in your application. We record that information in TFS itself. So it's actually a separate warehouse than the one for the local development, right? And the third experience is, as part of you running team build, we now will show you a report that will show you the exact set of tests that were impacted. In fact, let me show you, let me see if I've got an example of that report. Hopefully I kept it around. If not, you can take a look later on. Okay. Queued, you go away. Let's see. Here. As you can see on the bottom of my screen, it actually tells me when I ran my nightly build, 21 tests were impacted. But what is really cool is we'll actually tell you what the impacts were. So you can now look at the changes that impacted the test, right? So there was a question at the back.
Is it possible when the team build set up like a continuous build to only run the impacted test or run your full suite of 9 tests with them?
Okay, so the question was, can you set up your build so that, let's say in continuous build, it'll run your impacted tests, and with full nightly build, it doesn't? You can set all this up in your build definition. So the answer is yes, and if I can bring up the build definition, let me actually go back here. Automate tests. Let me see. There we go. There's a setting called, sorry, we change this UI all the time, so I'll constantly have to look around where that setting is. There's this thing called analyze test impact, right? So for one build definition, you can say, you know what, don't analyze test impact. For another one, you can enable that setting.
No, but I mean as far as which tests to run. Can you only run the tests that are impacted on the continuous build and then run your full suite at night?
So the answer is, so you're trying to basically cut down your build time, correct? The answer, we don't have that feature in this version, no. I have, sorry, quick question.
What languages then are supported?
The question is what languages are supported. We support VB and C#. It's primarily managed languages for this version. I know there's a lot of gasps. If you're a native developer, you're like, oh, I got screwed again. But okay, when will it be available for native? I can tell you one thing, right? We are planning to invest more in native support, absolutely. Now, not for Visual Studio 10. However, we've heard it loud and clear that customers want all those features and the 100% parity between native and managed. So we are addressing that problem after Visual Studio 10. I have 15 more minutes. I've got 2 really cool demos still. So please apologize. I apologize if I have to, if I don't answer your question right now. But afterwards, you can grab me. OK. Now, we've covered scenario 1, which is IntelliTrace and non-repro bugs. We've covered scenario 2, which is test impact analysis and being able to choose the right tests. And now I'm going to talk about the third scenario, which is how do you do performance analysis across multiple tiers? So this is a classic scenario right here. You have on the client side, you're running client-side script, let's say JScript. On the mid-tier, you have your data access layer. So let's say you have a web service running in the mid-tier, and there is some link code there. And ultimately, in the back end, you have a database, right? And now you have this scenario. An unhappy user comes to you and says, the user's in red, by the way, red versus blue. Yes? Halo reference, anyone? No? OK. So the red user says, when I try and load the orders page, it is damn slow. And the developer says, well, I honestly don't know where the problem is. It could be in the front end because the JScript code is bad. It could be in the mid-tier, or it could be in the stored procs, let's say. But how do you find that out? So can I see a show of hands? Who's aware that we have a profiler or performance analysis in Visual Studio 2008 today? Hands up. Wow, that's a lot more than I anticipated. That's great. OK, so now I would say we have a pretty compelling performance analysis tool in the product today. However, it really was meant to be a single-tier performance analysis tool, right? It will do great on, let's say, your mid-tier. In 2008, we don't support JScript profiling, but guess what? In 2010, we do now. But very importantly, for this scenario right here, for example, I would love to find out, you know what the performance of the page requests were, but not only that, what were the queries that were called as a result of those page requests? So let me show you another demo right now. Let's go to our classic application, reset window layout, everything magically fixes itself, beautiful. And let me just close all these documents because I don't need them anymore. All right. So how do you go about diagnosing this problem? You go to debug menu and then say start profile analysis. And that's another feature or capability that we've added in 2010, where you can start the profiler from the debug menu. We're going to, for now, I'm not going to dig through all the other types of performance analysis that requires half a day. But let's kind of take my word for it and select CPU sampling. I'm going to look at the web application. And you notice there is now this checkbox called Enable Tier Interaction Profiling. And it kind of does exactly what you expect it to, in which case now I can see what the interaction between my tiers are. But not only that, what is the performance characteristics between my tiers as I run my application? So right now, this is going to, in a second, throw up a dialog, if I remember correctly, where it's going to ask me for creds. There we go. Yes, really. OK, so this is going to start up my application. And then what I'm going to do is I'm going to exercise some of its functionality. And when I exercise the functionality, the profiler is recording what the performance characteristics of my application are. So let's do the same scenario. Model layer planes. Or maybe I didn't click. OK, I clicked it now. OK. Yep. Are we there yet? This is my previous app. Ah, excellent. All right, so let's choose one of these, not very important. Choose another one. Hey, there's our bug. Good God, okay. Now, regardless of that, let's still just go ahead and look at this. The actual results that came back from the profiler. Okay. Again, what I'm going to do is I'm just going to expand full screen just to make sure you guys can see it. So the first thing that you notice is that we've added this beautiful chart where you can see the performance characteristic of the application as it was running. You can actually do things like, you know what? I only want to focus on this little spike right here. So you can click that, right-click on that, and just filter and really zoom in. Think of it as your favorite mapping software, right? This is your world, and then now you can reduce and zoom, really focus on the area that you're interested in. But the feature that I really want to show you is this thing where from the current view, you can select tier interactions. And when you do, I love this feature. Check this out. First of all, you now see all the page requests that were made in your application. You can see how many requests were made for each page, how long did it take for each page to execute. But wait, there really is more. Wouldn't it be nice if I could see the exact set of database queries that were called as a result of that page request, right? So this is going to be a killer feature, guys. I mean, now, not only that, you can see, you know what? It took like 7 seconds, whatever, for that page request. But now I can break that down to how long did it take to do each individual database call, right? And if you really, really want to, you can then double-click on one of these and look at the exact database call that was made. So again, imagine how you'd go about analyzing a performance issue like that today, right? Where you have to either say, you know what, I don't know how to solve the problem, or try and figure out some kind of tracing or write some code to try and figure out what's actually going on. So, okay. So this was the performance analysis that I want to show you, and you can basically see the page requests and calls. One of my favorite areas, the debugger. We've added no fewer than 16 features to the debugger, but unfortunately, I'm going to cover only 2 of those today. If you want to see more of those, or if you want to find out more of those, please send me an email, and then I'll be more than happy to share with you the demo applications or the actual documents on what those features are. The first feature that I want to talk about is what we call collaborative debugging. So the scenario is this. You're a developer and you're debugging a problem. Let's actually do that right now. Close all these windows. And do the magical reset layout. OK, my favorite feature again. Control comma, add item. There we go. All right. So you're a developer, and someone just checked in some horrible piece of code. That person shall remain nameless, but they really did. And so you set a breakpoint on where the problem is, and press F5. This time around, of course, when I go through my scenario, what should happen is that the debugger will hit the breakpoint, and then I can go ahead and actually debug the problem. But the scenario is that I am a developer, and I am working on a problem where I'm not exactly sure what is going on here. So I need to collaborate with someone else, let's say one of my teammates, to try and figure out what actually happened. All right, I hit my breakpoint. Wait. Now, the first feature that we've added is the ability now, you might have seen some of this, is you hover your mouse over a variable, see its value, but now you can actually pin it to the editor. How is that? Okay, you can see there's this pin thing now. So one of the biggest complaints that we get is, damn it, man, when I move my mouse, why does that thing just go away? No more, it's all fixed. The next thing is you're like, you know what? It's funky. This just doesn't look right to me. So what I'm going to do is I'm going to ask my mate, Adam. There is something wrong here. You can now, just like you have your Post-it notes, add comments to your data tip. So how many times is it where you're watching a variable as you're stepping through and you got your little Post-it note and you're writing some notes? Well, you don't have to do that anymore because you can now associate that comment with the data itself. But what's really cool here is that at this point, you can say, you know what? I really want Adam to look at this problem. But I don't want to send him a long email saying, Adam, do X, Y, and Z to get to the repro. How about if I just go ahead and export that breakpoint? Let's see. Quantity bug breakpoint, right? This is literally an XML file that you can attach to an email, check into your favorite version control. So it can go anywhere that you want to. Put on a share, right? But what's also really cool here is that I can also go to the debug menu and say, export my data tips. So we're going to say a quantity bug data tip. Now, I'll put both of these files on my desktop. And what I'm going to do is I'm going to stop debugging. Now, just to show you, I'm going to delete this breakpoint, and I'm going to delete the data tip as well. Now I'm going to switch hats, and I'm Adam, and I'm going to come in. The first thing that I want to do is bring up the breakpoints window. And you know what? I'm going to import the breakpoint that Habib sent me. So, and voila. Now I know where Habib was telling me about the problem. But what I can also do is go to the debug menu and import the data tip. Now I have both the breakpoint and data tip. And guess what? The only thing I have to do now is press F5. What this will do now is obviously stop at the location where my friend co-developer told me where the problem is. But not only that, it will actually then show me the data that my friend developer was seeing when he was debugging the problem. Yeah, so the question was, when I check my coding, will the data tip get checked in as well? And the answer is no. You have to explicitly do that yourself. You have to export, then check in. All right, so as I go through this scenario now, add to cart, voila. Not only do I have the breakpoint and it stops exactly where the other person told me, but I also see the value of the variable and what the comment was that the person wanted me to actually see. It's a completely encapsulated debugging session that you can hand off to your developer or friend now. Okay. So the answer was, does the person need to run the exact same code? And the answer is yes for this version. The logic isn't smart enough right now to do the mapping when let's say you've changed some lines of code. Yeah, it's right now purely based on line by line. So the answer is, does it use source server? You could absolutely set up source server to do that as well. But if you're not using source server, it doesn't. I have 2 more minutes. I want to show you something else. I've explicitly left this slide in here, so later on, when you guys go through the presentation, you can see exactly what all the features are with the pinnable data tips. But one of the most important features here, I think, in 2010 is our ability now to debug crash dump files. Can I see a show of hands? Who here knows what dump files or crash dump files are? Excellent. Who here actually knows how to debug using dump files or crash dump files? Wow, more than I thought. That's awesome. Who here knows what SOS is? That's pretty impressive, I gotta say. That's pretty good. But now, we've made it that much easier to debug your managed crash dumps. Let me show you what that experience looks like. It's pretty cool. So I've got an application here, which is actually a WPF application. And I, as a user, let's assume I don't have a debugger, so I cannot actually go ahead and debug any problems in this application. Just to make sure. OK. Let me try it again. Come on, hamsters. Run. Yeah, quad-code hamsters. I'll. OK. You know what? It's going to be easier to actually do it this way. I'm going to set this as my startup project. But I'm going to actually press Control F5 to. I'm not going to debug it, but just launch the application. All right. So I'm a developer, or actually a tester right now, and I'm clicking through the application, testing some things, and then when I click on the last row, badness happens, right? How do you go about debugging this today if you don't know how to use SOS with Visual Studio or WinDBG? Well, one of the features that you might be aware of is the fact that you can start up Task Manager, go and hunt down the exact application, right-click, and say, create dump file. This will then start writing a dump file, and it'll actually then show me the exact path where the dump file is on my disk. So you don't have to have Visual Studio or anything else installed on your machine to be able to debug the dump file. And once it's done, I'm just going to copy this. And then in Visual Studio, Control O to open, paste the path, open. This is now how easy it is to debug a dump file. If you're an SOS user, check this out. First of all, we'll tell you the architecture of where the dump file was taken. We'll tell you what the OS and CLR version are. We'll tell you where all the modules are. But more importantly, you can just go ahead now and say debug. A managed dump application, right? This is something that you cannot do today. And what this will do now is, well, what it should do is put me at the exact location where the crash happened. How do I go about debugging this, right? Here's a trick. Bring up the Quick Watch window. It's Control-Alt-Q, right? Then type in $exception. It'll tell you the exact reason of why the exception happened, which was actually it was unable to cast from one type to another, right? So now, A, you were able to debug the crash dump file, which is a managed crash dump file, and B, using the $exception, you can now actually look at the reason of why the crash happened. So if you are debugging the deploy application, this should make life much, much easier. Again, for your reference, I've put a screenshot of what all the features and functionalities are. OK, so that is pretty much the end of my talk. I want to leave you with a question. Having seen this today now, how many of you would say you would love Visual Studio 2010? Can I see a show of hands? Yeah, OK. Thank you, thank you. It's been my absolute pleasure presenting to you guys. Please, please, if you do have any questions or anything else, send me an email, and I'll guarantee you a 24-hour reply. If you have any other questions, please send me to the side here, and I'll be more than happy to answer your questions.